All right, so number 2, x plus 2, x to the 5th, and then you have to have a plus 0x to the 4th, minus x to the 3rd, minus 2x minus 3. Does that answer sort of your question?
Yeah, it's just that I was using 0x to the 3rd.
Yeah.
Because that's what it says on here.
This what? Doesn't say 0x to the 3rd.
Well, it says x to the 5th minus x to the 3rd.
Right, that's minus 1, right?
Yeah.
Okay. All right, so this is x to the 4th, which gives me x to the 5th plus 2x to the 4th. I immediately change all the signs before something awful happens. Negative 2x to the 4th. Bring down the next one, negative x to the 3rd. What times x gives me negative 2x to the 4th?
2.
Negative 2x to the 3rd, right? That's negative 2x to the 4th minus 4x to the 3rd. Immediately change the signs before something awful happens. I get 3x to the 3rd. Bring down the next term. Oh, did I skip one back here? Whoa, I did something really wrong here. Hold on. Hold on. There should be 2x squared. Plus 2x minus 3, right? I skipped something when I wrote it down. So detail like that. Okay, so I got to bring down this term, which is negative 2x squared, right? Okay, what times x gives me 3x cubed? Plus 3x squared, right? Because you need an x to the 3rd.
Oh, x to, I thought it was x.
Okay, so this becomes 3x to the 3rd plus 6x squared, right? Minus minus, before something bad happens, I get negative 8x squared. Bring down my plus 2x. What times x gives me negative 8x squared?
Negative 8x.
Negative 8x. I get negative 8x squared minus 16x. Change the signs before something awful happens. 18x. Bring down my negative 3. What times x gives me 18x? 18. So I get 18x plus 36. Change my signs if something awful happens. Negative 39. So it becomes minus 39 over x plus 2. Ta-da!
Because you didn't do it right.
Well, yeah, no, really.
That's fair. I just want to check, see if it's got a remainder. If it's a remainder of 0, it's a factor, right? Beautiful, that's what I want. If it's got a remainder of any other number in the universe, I don't want that one. And I'm certainly not going to bother to do this if I've got a better trick. Here's the better trick. It's what you're going to do. What would make this, what would be the solution? If x plus 3 is a factor, what would be the solution? X would be what? Oh, the crowd went quiet. It would be negative 3, wouldn't it? So if this, so the zeros would be found at negative 3. So what I'm going to do is I'm going to put the negative 3 in and see if I get 0. Right? Yeah. So I'll put the negative 3 in. Boom. 2 negative 3 squared minus 4 times negative 3, and I get 9, 18 plus 12, 30. Is that a factor? No. Okay. That's it. Try it on the next one, and then we'll talk even more. Try it on number 2. Do number 2. Number 2 says x to the 5th minus x to the 3rd minus 2x squared plus 2x minus 3 divided by x plus 2. Is that a factor? What do? Plug in a, and I should get 0 if it's a factor. So let's plug a negative 2 in there. lot of work. I got negative 39. Oh, sorry. I did it in my head. Working hard. Give me a second, Mr. Wolf. I'm trying to find zeros without having to actually go and do long division every single stinking time. But notice something interesting. When I took these two and divided them a while ago, what was the remainder? 30. And then when I did this one right here, I didn't do that in my head so fast. What did I do? Went back a page. The remainder is negative 39. This is called the remainder theorem. It's not completely understood why it even works. In all the cases it seems to work in. But it works. If you put a number in, you put the 0 in, it gives you the remainder. So that's a way you could check what? Your long division, right? If I asked you to divide these two, you could use the remainder theorem at the end, and you better plug in negative 4 into this ugly thing here. If you do it successfully, hopefully you get 4,936. Well, that's got to be right. No way that could happen on accident, right? Does that make sense? This is called the remainder theorem. So on back at 7.3, there's a bunch of problems. It says use the remainder theorem to determine whether it's a binomial. So you're going to go ahead and use the remainder theorem by plugging in negative 1 in that first one. If you get 0, is it a factor? Yes. So you can write yes or no. If you get anything other than 0 for the remainder, it is not a factor. Yes, sir.
So if we're,
so number 5. Number 5, I would have 2x to the 4th plus 4x to the 3rd minus x squared plus 9 divided by x plus 1. I take one look at this and go, aha. I'm going to put a negative 1 in. I get 2 negative 1 to the 4th plus 4 negative 1 to the 3rd minus negative 1 squared plus 9. This gives me 2 minus 4 plus minus 1 plus 9. That would be 11 minus 5, which is 6. And so no, that is not a factor, so I do not want to choose to do the long division version of that because that would be painful and hurt my feelings.
no, it says yes or no. You're supposed to write yes or no.
Minus 3x squared minus 10x plus 3 divided by x minus 3. So I'm plugging in 3, so that's 2. 3 cubed minus 3. 3 squared minus 10 times 3 plus 3. That's 27 times 2 is 54 minus 27 minus 30 plus 3. So that would be 57 minus 57 or 0. So yes, it is a factor. So if I'm trying to factor this out, I could usually use that for my factor. Uh, 3x squared plus 4x minus 12 divided by x plus 5. Love it so far? Okay. Now what did I do over here? I said I'm going to use the 0, right? If x plus 4 is a factor, I'm going to use the 0. So I'm going to put a negative 5. I'm going to put it right here. And then I'm going to write this, making sure I don't forget any holes, right? 3, 4, negative 12. Trust me, you're going to want to do synthetic division. Those of you thinking right now, I like this, this is cool, I kind of like the way it flows and feels good. You have to know how to do this because they're not always going to be like this, and I'll explain that in a second, where it's x plus some number, x minus some number. So that synthetic division only works for this. But, that said, ... We're going to be doing 100,000 of these problems. So if you're doing them all this way, you are going to use up so much paper, I can't even tell you. Whereas this is going to be much nicer on your life. Okay? So we need to learn synthetic division just to make our lives better. So I'm going to bring down the 3. Boom. That's what we did the first time over there. 3 times negative 5 is? Negative 15. 4, you know what, I should do this problem over here. Should I do this problem over here? Be more example. No, okay, fine. Now 4 minus 15 is? 4 plus negative 15 is?
Negative 11.
Negative 11. Negative 11 times negative 5 is? 55. 55 minus 12? Or negative 12 plus 55? 33. No, 43. Thank you. Okay, so this is where the magic happens. This number right here is 1 power less than that one right there. So this is going to be 3x minus 11, 1 power less, which means x goes away, plus, what's the 43 then? The remainder. 43 over 3x squared plus, oh no, but I divided by x plus 5.
That's a lot easier.
That is a lot faster and, generally speaking, easier. Okay, does that make sense? All right, try the next one, see how we do. So that's going to be 3 into 1 minus 5 minus 12. No breaks in here, no mistakes. Bring down the 1. 1 times 3 is 3. Negative 2. Negative 2 times 3 is negative 6. Negative 18. So I've got x minus 2 minus 18 over x minus 3.
I was right, Ricky. And you said I was wrong. Yeah, but I still got the right answer. I still got the right answer. No, I still got the right answer.
Oh, Lord. 1, 1, 0, negative 3, 0, 12, right? Bring down the 1, I get negative 1 gets 1, negative 2 gives me 2, gives me 2, gives me negative 2, which gives me 10. Lower its power by 1, so I get x to the third minus x to the second minus 2x plus 2 plus 10 over x plus 1.
Oh, I did that wrong. Forgot the negative 3.
Oh,
At the very
is it a
end,
negative 3? Yeah. What?
so like if at the very end instead of getting 10 you got 0,
That would be a factor, and it's what we're going to be looking for as time wears on.
okay.
But we still have to do long division in case we need to do it, so it all works out.